Hello everyone! In this video, we're gonna discuss and solve a problem regarding flow measurement in weirs. There are numerous number of devices used to measure the flow of fluids. In any of these devices, the Bernoulli energy theorem is greatly utilized, and additional knowledge of the characteristic and coefficient of each device is important. In the absence of reliable values and coefficient, a device should be calibrated for the expected operating condition. Now let's talk about weirs. Weirs are overflow structures which are built across an open channel for the purpose of measuring or controlling the flow of liquid. Weirs have been commonly used to measure the flow of water, but it's now being adopted to measure the flow of other liquid. The formulas and principles that will be discussed on this chapter are general, applicable to any type of liquid. Here's some classification of weirs. According to shape, weirs may be rectangular, triangular, trapezoidal, circular, parabolic, or of any other regular form. The most commonly used shapes are the rectangular, triangular, and the trapezoidal shapes. According to the form of the crest, weirs may be sharp-crested or broad-crested. The flow over a weir may either be free or submerged. If the water surface downstream from the weir is lower than the crest, the flow is free. But if the downstream surface is higher than the crest, the flow is submerged. Here's some definition of terms. Here's the path lines of flow over a rectangular, sharp-crested weir. Here's the following formulas that we can use in solving the fluid flow measurement in weirs. Now, let's move to the example problem. Here's the problem. During a test on a 2.4 m suppressed weir 900 mm high, the head was maintained constant at 300 mm. In 38 seconds, 28,800 liters of water were collected. What is the weir factor? Now, let's write down all the given values in this particular problem. Volume converting liters into meter, we have 28.8 cubic meter. For L, we have 2.4 meter. And for time, we have 38 seconds. H, we have 0.3 meter. And for area, we have 2.88 meter cube. In this particular problem, we can use the general formula for a discharge through a rectangular weir. Here's the formula, where Q is the water flow rate in cubic meter per second. L is the length of the weir in meter. And H is the head over the weir in meter. C sub W is the wear factor and it is a unit less. And since the flow is steady, we can use the Q equal to volume over time to solve for the flow rate or discharge. And we can now distribute the given values in this formula. Flow rate is equal to 28.8 cubic meter divided 38 seconds. And now, we have the value of flow rate which is 0.7579 cubic meter per second. And for the next step, to solve for velocity approach, we can use the formula velocity approach is equal to flow rate over area. Now, let's substitute the value needed in this formula. Velocity approach is equal to 0.7579 cubic meter per second divided 2.88 meter cube. And now we already know our velocity approach is equal to 0.26316 meter per second. And to solve for the head of the velocity of approach, we can use the formula velocity approach squared divide 2 times gravity. Now let's distribute again the needed value in this formula. H sub V is equal to 0.26316 squared divide 2 times 9.81. Now we have the value of the head of the velocity approach which is 0.00353. Since we already have the needed values for solving the wear factor of this particular problem, we can now substitute it in the general formula for a discharge through a rectangular wear. By calculating this, we can now get the value of our wear factor. Wear factor is equal to 1.891 in this particular problem. Now, we are done with our discussion and example problem. Thank you.